Hello, Genians! Our problem solving for today is about cylinders. Cylinders that are filled with water around half, and the other cylinder is 1/3. And here we will be looking for the height of the water displaced when a rectangular block is dropped into the water and immersed into the cylinder. And the other problem also it's about finding the rate of change of height of the oil. So halika, samahan niyo ako. We will be solving two problems. Our past GE board exam, which was given last November 2013. The question: a concrete cylindrical tank has a diameter of 14 meter and is half filled with water. A cement block in the shape of a rectangular prism is dropped into the tank until it is completely submerged in water. Suppose the block is 7 by 9 by 11 meter. How many meters does the water in the tank rise? So here we have to use the volume of a cylinder and the volume of a rectangular block. Now, if we have this cylinder, we have the cylinder and we have the block. We have the block with a dimension of 7 by 9 by 11. So this one here, we're looking here for the meter when this one, the block drop in the water. So this one, it is half filled of water. And this has a diameter of, from here to here, this is the radius. So the diameter is 14, so the radius is equal to 14 divided by 2, which is equal to 7. Now this is half filled of water. Now if this rectangular block will be dropped in here in the water, of course the water will rise, so it will become the water will rise from the original position, going to example this side. So the block is completely submerged inside the water. So that means there is a height difference from the original to the new height, which is equal to h. We designate it as h. Now, to solve this one, we will use the formula for the volume of a cylinder, which is equal to pi r squared times the height. And the volume of the rectangle, we designate as VR is equal to the length times the width times the height. Now in this case, of course the volume are the same. Whether you put the block, still the volume of the water the same. So we can equate this to BC is equal to VR. Now, here we can have the original volume, which is equal to pi r squared H, and the volume of the block, because when this one rise, the height of course will be the same. So length times the width times the height. Substituting the values, pi r squared h is equal to the length, which is equal to 7 by 9 by 11. So we have only one variable because r is equal to 7. Therefore, h so if we will substitute the value of r, which is 7, squared times h is equal to 63 times 11, 97, 63. Therefore, the height is equal to 4.5 meter. So this is the one we're looking for, the meters. How many meters does the water rise? So it will rise at the height of 4.5. This one, the original one, then is gone up. So the answer is 4.5 meter. So the answer is, the height is equal to 4.5 meter. This is the one we're looking for. Our second question, this was given last November 2014. The question, a vertical cylinder has a circular base of radius 3.5 meters and a height of 3.95 meters. It is 1/3 full and is being filled with water at a rate of 0.5 meter cube per second and oil at a rate of 0.5 meter cube per second. The specific gravity of oil is less than that of water. How fast is the surface of oil rising? So to solve this one, we have to, of course, we will draw. So if we will draw the cylinder, and here is the water. So we have this one, the DH. Because we're looking for the DH. The height. So now here, now to solve this one, we have to use the formula of the volume of a cylinder, which is equal to pi r squared h. Now we have pi, and the radius is given here to be 3.5 meter, so 3.5 meter squared times, of course, the height. Volume therefore is equal to 38.48 h times the height. Now, because we are looking here for dh dt, the change in height with respect to the time. So we're looking for dh dt, the change of height with respect to the time. Therefore, we can differentiate this one. dv dt therefore is equal to 38.48 derivative of h over the time. Now, since we have this the rate of the oil, which is equal to 0.5 meter cube per second, so we can substitute this one on dv dt, the 0.5. So dh dt therefore is equal to dv dt, which is equal to 0.5 meter cube per second divided by 38.48. This is the one here. So derivative of h, so the change of the height with respect to the time is equal to the value of this, which is 0.5 divided by 38.48. Therefore, derivative of h with respect to time or is equal to 0.013. This is the one we're looking for. How fast is the surface of oil rising? This is the one here. dh So our answer is dh dt is equal to 0.013.